The first part of refraction, we zoom more into how the light ray bends in different medium, and as well as introducing the two formulas for refractive index. N equals to C over V, which is in terms of the speed of light in vacuum as compared to in the medium, and also the refractive index N equals to sine I over sine R. But in this second part of refraction, we'll zoom more into the second equation, which is the Snell's law, N equals to C over V. To better understand how we can use the second formula, we need to understand about this principle of reversibility of light, okay, which states that regardless of how many times a light ray has been reflected or refracted, it will always follow the same path when the direction is reversed. What do I mean by that? You can take a look at the picture A. Okay, light is traveling from the direction of A towards B. I move from vacuum into a material and out of the material. So this is my angle of incidence and X, and then this is my angle of refraction, Y. Okay, but light doesn't always move in this way from A to B. If I were to shine the same light in the reverse direction, that means you look at the second picture B, when I shine light from B towards A, it will actually follow the same path with the same amount of bending. That means this angle X will still remain, this angle Y will still remain. It's just that you can see the arrow direction change. So in this case, light move from A to B, same pathway as it moves from B to A. Okay, why do we need to understand this? Because if you were to recall the Snell's law, okay, N equals to sine I over sine R, this is always with respect to a vacuum. Okay, it means that we use N equals to sine I over sine R when light is moving from a vacuum or air into another medium. So the angle I is always the angle in the vacuum or the air first over R, which is the angle in the medium. But sometimes light can move in the opposite way. Instead of moving from air or vacuum into the medium, it can also move from a medium into air or vacuum. So there is two ways of writing the formula. It can be N equals to sine I over sine R, or N equals to sine R over sine I. And we also learned that in the previous session that refractive index N must always be greater than 1. So how do we make that easier? Okay, we come up with this. Okay, two formulas. Instead of remembering N equals to sine I over sine R, we always take N equals to the sine angle in the air or vacuum over angle in the medium. Okay, if you were to recall, okay, it's always the same. There's consistency. The first formula, N equals to C over V, whereby C is the speed of light in vacuum over speed of light in the medium. Okay, so for the angles, it will also be the same. It's always sine angle in the vacuum or the air over sine angle in the medium. Okay, it's always vacuum or air first over the one in the medium, because the one in vacuum air will always be the bigger number. So your refractive index will always be greater than 1. Okay, if you can't remember, you can also take as the sine bigger angle over smaller angle to give you a refractive index that will be greater than 1. Okay, so we look directly into the examples. Okay, you can see this. Calculate the angle of refraction if the medium has a refractive index of 1.9. So they have given you the refractive index and I want to calculate the angles. Okay, so again, you come back to the formula for refractive index. The first one is N equals to C over V, which is in terms of speed of light. And the second one, N equals to sine I over sine R, which is in terms of angles. Now I'm not interested in speed of light. I'm interested in the angle. So I'm confirmed going to use the second formula. Okay, then you go and label in your diagram where are the angles that I'm interested in. I am always interested in the angle between the ray and the normal. So this is the incident ray. So this will be the angle of incidence. And this is the refracted ray. So this will be the angle of refraction. Okay, so remember, whenever I want to apply N equals to sine I sine R, it's always sine bigger angle over smaller angle, or sine angle in the air or vacuum, which is over here, over the angle in the medium. So this is correct. So I write down my formula, n equals to sine I over sine r. I sub in my number, 1.9 equals to sine I, which is over here, the angle in the air, okay, which is 90 minus 15, 75 over sine r. I don't know how much is this angle of refraction. So if I were to do my mathematics, I will get r equals to 30.6. But if you do not know how to do the mathematics, okay, I'm going to work on one example. I'm going to break out steps by steps. So if I want to make sine r my subject, okay, I will bring sine cross multiplication. Okay, I will become sine 75 over 1.9. And I'm not interested in sine r. I'm interested in r. So if I were to bring over, okay, in your calculator, you can press shift sine. It will become inverse sine. Okay, and it should be like that, sine 75 over 1.9. Okay, so I will do inverse sine, the entire ratio of sine 75 over 1.9. I will get 30.6. Okay, you may please try it on your calculator. Okay, next question. The refractive index of glass is 1.5. Determine the angle of refraction at JK. So I know that my light ray is moving into the glass. So I'll bend towards the normal. So it looks something like this. And then this is my angle of incidence, which is the angle in the air over the angle in the medium. Okay, so I'm going to apply my formula, n equals to sine angle in the air, which is I over sine r. So I will get 1.5 equals to sine 60 over sine r. So how do I solve for sine r? Again, I'll cross multiplication, I'll bring it up. So it equals to sine 60 over 1.5. So, but I'm not interested in sine r, I'm interested in r. So it's sine inverse sine 60 over 1.5. Okay, if you work out, you should be able to get the answer of 35.3 degrees. Next, okay, calculate the refractive index of the semicircular glass. Okay, so again, I mark up my angles. This is my angles that I'm interested in. It's between the ray and the normal. This is the angle. Okay, so you just take note that now my angle of incidence is over here because my arrow is going here. Okay, and then the one that comes out is the one that gets bent. This is my refracted ray. Okay, so now this is I, this is R. My I is 32, R is unknown. Okay, R is actually known now. Okay, it's 90 minus 20, 70 degrees. Okay, but now I want to calculate refractive index. So I know that I always need to take n equals to sine angle in the air. So now my angle in the air is no longer sine I. My angle in the air is sine R, or sine bigger angle is the sine R over sine I. I'm moving from medium to air, not air to medium now. Okay, so my formula becomes sine R over sine I. So sine R is actually sine 90 minus 20, so it's sine 70 over sine I, which is 32. So if I were to work out, I should be able to get 1.77. Okay, you should know A is confirmed up because refractive index cannot be less than 1. Okay, next few examples is a good chance for you to practice on your formula. Okay, so you have this angle P is your angle of incidence, and this 30 degrees is your angle of refraction. So you want to calculate the angle P given the refractive index. Okay, so you should be able to get n equals sine I over sine R, because I, again, is the angle in the air of vacuum 1 first over the angle in the medium. So you should be able to get, sub in the formula, 1.25 equals to sine P over sine 30. Okay, so I solve for my P, I should get 38.7. The next one, I want to calculate refractive index of the glass block. I need to add my normal first because I need to determine where is my angle. So in this case, this is my angle I, and this is my angle R. In this case, you should know the angle in the air one first. So you should be able to get n equals to sine r over sine I, not sine I over sine r, because r is the angle in the air one first. Okay, so you get sine r over sine I. So sine r will be 90 minus 40, you get 50. And then sine I will be 90 minus 82, you get 8. So the refractive index is 5.50. Okay, and then the next few examples are some of the effects of refraction. How come an object appears bent? You can read up on your textbook. Okay, so you can take a look at this pencil looking through a glass block, it will just appear bent. Half submerged object will also appear bent. Okay, the reason behind it, you can read through yourself. And why objects appears nearer to the surface. Okay, it's again because of refraction of light. When light leaves the from water into air into our eyes, it actually bends away from the normal. Okay, so you can just read up on yourself about this.